You're welcome to this section, and here we'll be looking at El Nino, Southern Oscillation, and La Nina as in relation to your Environmental Management IGCSE syllabus, which is an aspect that I've been asked by students to do a video on. Now, first, I need to clarify something. Now, the concept of El Nino and La Nina are both found in two parts of your syllabus where you look at ocean and fisheries. Now, they expect you to understand how El Nino affects fish distribution, how it affects fish distribution. Now, another part of your syllabus where these two concepts appear has to do with managing natural hazards. Now, and they expect you to be able to describe how El Nino, in that aspect, how El Nino affects or lead to or causes, how El Nino causes drought, how it causes drought and flooding. El Nino and Lanina in this aspect. So all our explanation will be based on this aspect, these two major parts, how El Nino affect fish distribution. And in this case, you should be able to bring in the concept of cold current and upwelling. Then, so here we'll look at the wind and also current, and also we'll look at pressure belt. Now, you even need to understand the concept of pressure belt for you to be able to answer effectively or understand effectively how El Nino and La Nina works. So quickly, I just mentioned upwelling. Now, upwelling are areas where minerals at the ocean floor are brought to the surface by current, and in this case, cold current. So areas that have cold current obviously have high amount of fish, have high fish distribution because of first upwelling, and also it's nutrient rich because of the upwelling. Now, let's see how this is how it will appear in the first aspect, which is ocean and fisheries. Let's say describe the El Nino Southern Oscillation phenomenon and its effect on fisheries along the Pacific coast of South America. Now, the El Nino Southern Oscillation is a term that is used to describe the changes in weather pattern in the Pacific Ocean. So you find out that if you look at this map around the Pacific, so what is happening here is strong, warm equatorial trade wind in a normal year. That means in this part, that this Pacific Ocean where it's taking place. Now, around this Pacific Ocean in a normal year, that means El Nino is not taking place and La Nina is not taking place. What is happening normally is that the warm equatorial trade wind tends to move westward. So it moves westward in this direction. So if you draw your cardinal point, this is never ever smoke weed. So that means this is in the west. So the equatorial trade wind, remember this is usually the line around the equatorial line, kind of, that divide the earth into two equal half. So the equatorial trade wind tend to move westward, so it's moving towards the west. Now, as it's moving towards the west, what will happen is it carries along, it's a warm current, and it carries along with it moisture. Now, as it moves towards the west, towards Australia, in this case, it will now what? It will now rise. As it rises, it loses the heat, causes a warm current, and what will now happen is it condenses to form cloud, which will now fall down as rain. So leading to high amount of rainfall within Australia. Now that is what is happening in a normal year. Then we have the Peruvian current, which will now come out from which is a cold current, which will now carry out the process of upwelling around the coast of South America, bringing about is cold. So there is, since it's a cold current, there is less moisture. So obviously there will be less rainfall. So since there is less rainfall, this area will now experience more drought and dryness within this part. Thereby, but the upwelling will help to increase the amount of fish distributed around Peru and this part of South America, because it carries out the process of upwelling also. That's in normal condition. So you see, when the trade wind reaches the coast of Australia, it has become very hot, wet, which rises and condenses to form convectional rainfall. Now, the high convectional rainfall can lead to flooding within Australia. Now, also in a normal year, upwelling of cooler nutrient-rich at the coast of South America means that there will be high concentration of fish because of this Peruvian current. Now, this leads to low amount of rainfall in South America. That's it. Now, but however, in an El Nino year, the opposite of a normal year occurs. And what happens is the equatorial trade wind will now move eastward. Remember, this is east, southwest. Now, you see the trade wind has changed direction. It moves eastward, and because it moves eastward, the Peruvian current, which is the cold current, will not be able, there will now be a thermocline here, that the thermocline will now drop for the cold current. So you see the upwelling will not take place, because this warm equatorial trade wind reaching the coast of South America, especially within the areas around Peru, it will now rises, convectional rainfall will now take place, and there will be high amount of rainfall here, which will now lead to low fish distribution during El Nino year, and thereby leading to less rainfall within Australia. Also, because the trade wind that causes the rainfall earlier in Australia has changed direction. So you see, in El Nino year, the opposite is the case. Now, weakening of the warm equatorial trade wind current flow eastward from the coast of Australia, Indonesia, towards South America. Now, this will lead to high rainfall in South America with drought condition in Australia, because there is no more rain, there is no more warm equatorial trade wind. Now, lack or no upwelling of cooler nutrient-rich water, which will lead to lack of nutrient in South America, therefore decrease in fish and marine creatures. Now, that is what happens in relation to El Nino and fish distribution. Now, in the case of drought, which is a natural hazard, you see, a drought is a prolonged period when rainfall is below average in an area. So you see, within an El Nino year, you find out that here might experience drought because of low rainfall. However, let's look at causes of drought. Drought is caused when there is lack of rain caused by prolonged high pressure. So you see why I said earlier, you also need to understand the concept of high pressure for you to be able to interpret Lanina effectively. So you see, if I draw the globe, this is the equator. And the equator is a low pressure belt. So it's low pressure. So you find out that the wind from the equator, that is why we said the equatorial trade wind, carries moisture and is low pressure. So it's a warm air mass. So it carries moisture and it rises and condenses and fall down as rain. So areas with low pressure experience high rainfall. Then areas with high pressure experience low rainfall because most of them are cold air masses, and once they are cold and they have high pressure, what they do is they sink. So areas within the subtropical high, the air mass there will move towards the equator, so they are sinking down. So you expect that they carry low. So areas within the subtropical high will now experience low rainfall. So let's look at this. So when they say lack of drought is an extended period of unusual dry weather when there is not enough rain. So the lack of precipitation can cause a variety of problems for the local communities, including damage to crop and blah, blah, blah. Now, in a normal condition, again, just like I explained earlier, so there is no need for me to dwell on this. You find out that, let's look at the effect of El Nino and La Nina on drought. First one is prolonged dryness. So now El Nino and La Nina also causes drought. Now, normally the trade wind blow west. Normally, I've explained that before, towards Australia. Now, the low pressure, because it's a low pressure equatorial trade wind, over Australia with air rising. So it's low pressure, so it will rise, cool, condense, form water vapor, and to form cloud, which grow into large precipitable size and fall down as rain within the Western Pacific. Remember, this is the Pacific Ocean, so this is the north, south, east and west. So within the Western Pacific, in a normal condition, there will be high amount of rainfall. But within the Eastern Pacific, there will be what? Since Western, there is low pressure. Within the Eastern Pacific, there will be high pressure. And look at the Peruvian current, which is a cold current, which moves towards the equator. Now, because of this high pressure, what will happen? There will be low precipitation and therefore low rainfall. And this area within the eastern part of the Pacific will experience drought. Now, in an El Nino year, the opposite is the case, where the equatorial trade wind will now change direction and move. The equatorial trade wind will change direction and move eastward. So at that point, there will be, this area will now have pressure will increase, so it will now turn to a high pressure belt, while this area will now become a low pressure belt. So obviously there will be warm air, high rainfall here, which it rises, condenses, and lead to high rainfall. While in the Western Pacific, there will be high pressure, thereby low precipitation, low condensation, and low rainfall. So you expect in an El Nino year, this area within Australia will experience drought, while this area there can be what? Flooding because of high amount of rainfall. Now, in La Nina, La Nina is when the normal condition become more extreme. So in La Nina, from the previous explanation, in a normal condition, the equatorial trade wind is still moving westward towards Australia from South America. So it's still moving westward. So this equatorial trade wind is now a normal condition. So when this condition becomes extreme, that's the trade wind blow more strongly towards the west, causing more warm water to build up near Australia. So this causes heavy rainfall and flood in this area of Australia. So it's just an extreme normal condition is La Nina. While because of that extreme normal condition, in the Eastern Pacific of South America, there is less rainfall than normal. So the rainfall will be less than normal. That's leading to high amount of drought. So in that case, this La Nina condition happens approximately every 2 to 7 years. That's it about El Nino and La Nina. So please subscribe, and thank you.